Good afternoon, students. Hello, everyone. Good afternoon. Good afternoon, everyone. How are you, students? Welcome. Yes, welcome, everyone. Yes, very good afternoon. So, students, before starting today's lecture, as always, please let me know quickly in the chat box. Am I audible? The screen is visible or not? And my voice is clear or not? Quickly, please let me know in the chat box. Everyone, is it clear? My voice is clear? The screen is visible, right? Okay, very good, very good. So students, in the last class, we were solving some questions, right? We were solving the question if the limit is infinity upon infinity, 0 into infinity, then how we are going to solve it, right? So if before starting today's lecture, please let me know quickly in the chat box. Is there any doubt regarding the last class? Everyone, please let me know in the chat box. Is there any doubt regarding the last class? If you have any doubt, please let me know quickly. Okay. So in the last class, we were seeing some important results, right? Some important results on the limits, and we were having the discussion. Yes, very good. JNV, yes. Good afternoon, JNV Balari. Good afternoon. So JNV Balari and everyone. So we were talking that in the last class we were discussing about the some important result, and then we were solving some questions, right? We were solving the questions. If the limit is infinity upon infinity, 0 into infinity, then how we will solve, how we are going to solve the questions, right? So if you have any doubt regarding the last class, please let me know quickly in the chat box. Okay, very good. So then, student, in today's lecture is going to be really important, because today we are going to look into the sandwich theorem. There is something called sandwich theorem, and then we will see the 1 raised to the power infinity theorem. Means if there is an indeterminate form of the kind of 1 raised to the power infinity, then how we solve that indeterminate form. Okay, so that is the agenda for today's class. So I hope everyone is clear about that. Okay, so shall we proceed? Okay, so let's start with the sandwich theorem, everyone. So students, what is sandwich theorem is? Sandwich theorem says that, let's say we have a 3 function, f, g, and h are 3 functions such that f of x is less than equal to g of x, and g of x is less than equal to h of x, like this. Okay, and it is also given that limit x tending to a, f of x is equal to limit x tending to a, h of x. Okay, yeah, this one. So limit x tending to a, f of x is equal to limit x tending to a, g of h of x is equal to 1. Then automatically you can say that limit x tending to a, g of x is L. Is this clear? So let's say you have a 3 function, right? F of x, g of x, and h of x. Okay, what it's saying is limit x tending to a, for f of x it is L, and for h of x is also L. And since the f of g of x is always between the f of x and h of x, okay, g of x is sandwiched. You can see that g of x is sandwiched between the f of x and h of x. So it means limit x tending to a, g of x will be L only. Is this clear? Is this clear? So let me explain it with the graph. Okay, let's suppose there is h of x. Okay, there is h of x. Let's say this is a curve of h of x. Okay, this is h of x, and this is x is equal to a. Okay, so at x is equal to a, limit of h of x is L. Clear? L. And since f of x is always less than h of x, right? As you can see, f of x is always less than h of x, right? So let's suppose the f of x will be some like this, right? But at x is equal to a, f of x is having limit L. So it will be something like this. So this is f of x. Clear? So as you can see, limit x tending to a, f of x kitna hai? L, and limit x tending to a, h of x is L, right? And it is given that f of x is always less than between g of x, and g of x is always less than between h of x. Clear? So it means my function g of x is always between the h of x and f of x. Is this clear? Right? Is there any doubt? Any doubt? So what does this mean? It means my function will always be between h of x and f of x. So it would be something like this, right? Something like this. But at x is equal to a, it should have to be passed through L. Yes or no? At x is equal to a, it should pass through L, because function is always between f of x and h of x, right? So this is g of x. Are you able to understand it? My function is always between f of x and h of x. So automatically, while crossing over x is equal to a, the function has to be passed through L, right? So it implies limit x tending to a, g of x will automatically become L. Is this clear? So this is known as sandwich theorem. Is this clear? This is known as sandwich theorem. So why the sandwich theorem is important? I'll tell you is that sometimes what happens is, sometimes you will be given a function whose limit you have to find, but directly finding that limit, it's little difficult. Okay. So what we do, we find two other functions such that my f of my original function is between the two other functions, and we can find the limit of those two functions. And if the limit of those two functions at x is equal to a is equal, then automatically you can say that limit x tending to a, f g of x is L. Is this clear? So that's why the sandwich theorem is really important. Don't worry, we will solving some questions so that you will get the idea how the sandwich theorem works. But the fundamental is clear. What is sandwich theorem and where we use the sandwich theorem? Quickly let me know in the chat box, everyone. Okay. So let's solve this question. Okay. The question is saying that 1 minus x square by 6 is less than equal to x sin x upon 2 times 1 minus cos x, and it is less than equal to 1. So question is saying that find the limit of this function. Find the limit of this function x sin x divided by 2 times 1 minus cos x, where x is tending towards 0. As x is tending towards 0, so as you can see, it is a 0 by 0. Right? It is a 0 by 0. Right? So how we are going to solve it? Please pay attention now. सबसे पहले let f of x is 1 minus x square by 6. Right? F of x is 1 minus x square by 6. So let's quickly find out limit x tending to 0 f of x, which is nothing but limit x tending to 0 1 minus x square by 6. Right? Since it is not an indeterminate form, so directly we can put the x is equal to 0. So we will get 1. Clear? Okay. So now let's suppose let h of x is 1. H of x is 1. So similarly, limit x tending to 0, h of x will be limit x tending to 0, 1. Will automatically will give us 1. Is this clear? Is this clear? And let g of x is x sin x divided by, yes, very good, January, 2 times 1 minus cos x. Clear? And according to question, as you can see, so according to question, f of x is always less than equal to g of x, and g of x is always less than equal to h of x. Yes or no? Right? And limit x tending to 0 f of x is equal to limit x tending to 0 h of x, which is 1. Right? So automatically you can say that it implies limit x tending to 0 g of x kitna hona chahiye? That should also be equal to 1, isn't it? Isn't it? So you can say that, so it means, so you can say that limit x tending towards 0 x sin x अपॉन 2 into 1 minus cos x कितना होना चाहिए 1. Clear? Is there any doubt? Is there any doubt? Tell me quickly in the chat box. Did you see the application of the limits? Did you see the application of sandwich theorem? Sorry. Is this clear? So we found the limit of f of x, h of x, and they are equal. So automatically the limit of g of x at x tending towards 0 will be 1. Is this clear, everyone? Please let me know in the chat box. Is there any doubt in this question or not? Okay, very good. If it is clear, then let's solve this question. Okay, let's solve this question. So question is saying that find the limit x tending to infinity n upon n square plus 1 plus n upon n square plus 2 plus n upon n square plus 3 as so far up to n upon n square plus n. So we have to find the limit of this. So first of all, how many of you are thinking that answer would be 0? Tell me. Some people might be thinking that, sir, this is nothing but n upon n square plus 1. When we'll find the since the degree of numerator is less than degree of denominator, so it will give us 0. It will give us 0. It will give us 0. So 0 plus 0 plus 0 will give us 0. So answer would be 0. How many of you are thinking like that? No, it shouldn't be 0. Why? Because x is tending towards infinity, right? So this value will not be exactly 0, right? This is not exactly 0. So it will be very small number, right? And since n is tending towards 0, so you are adding a small number infinity times, right? So it would be some number, but definitely not 0. Is this clear? Is this clear? So that's why the limit should not be 0. Okay, I know some people will think, sir, why limit should be 0, right? Find the individual limits and it is 0, but no. Is this clear? Tell me quickly in the chat box. Clear? Okay, very good, Janvi Balari, very good. So if it is clear, then students, how we are going to solve it? How we are going to solve it? Can anybody tell me in the chat box how we can solve this question? Without sandwich theorem, it is very difficult to solve this question, right? One second. Here n is tending towards infinity. Okay, here n is tending towards infinity. X tending toward infinity makes no sense, right? Because there is no x in the expression. So here n is tending towards infinity. Okay. So let's solve this question. Okay, this is very important question. Okay. So how we are going to solve it? See, what is this number? What is this expression? N upon n square plus 1 plus n upon n square plus 2 plus n upon n square plus 3 and so on so forth up to n upon n square plus n. Right? Tell me, is this number is less than equal to n upon n square plus 1 plus n upon n square plus 1 plus n upon n square plus 1 n upon n square plus 1. Is it correct, right? Because I have just decreased the denominator of each terms, right? So this means automatically I have increased my number, right? I have increased the value of my expression. So it means this value is less than equal to n upon n square plus 1, n upon n square plus 1, n upon n square plus 1, like that, right? And tell me, is it greater than equal to n upon n square plus n plus n upon n square plus n plus n upon n square plus n, so forth, so up to n upon n square plus n. Right? Now what I did, I have increased my denominator for each term, so automatically the number will decrease, right? So it means the value of expression will decrease, right? Is this clear? So it means my given expression is between this expression and this expression, right? So now let's call this f of x. Let's call this g of x. And let's call this h of x. Clear? Is this clear? Any doubt so far? Now what I'll do using sandwich theorem, limit n tending towards infinity f of x निकालते हैं. Okay, limit n tending towards infinity f of x कितना आएगा? It is limit n tending toward infinity, n upon n square plus n plus n upon n square plus n plus n upon n square plus n, so for up to n upon n square plus n, right? So it is limit n tending toward infinity. How many times this term is there? N times, right? So it means it is nothing but n into n upon n square plus n. Clear? So it means we are getting limit n towards infinity, n square upon n square plus 1, right? So now it is infinity upon infinity, right? Now it is infinity upon infinity. So you know that when infinity upon infinity term expression is there, indeterminate form is there, how we solve it? By creating infinity in denominator, right? So what do you do? Divide numerator and denominator by n square. So as you can see, we can divide the numerator and denominator with n square. So we will get 1 upon 1 plus 1 upon n square. Clear? So now it is no longer in indeterminate form, right? We got rid of the indeterminate form. Yes or no? So now substitute n equal to infinity. What you will get? 1 upon 1 plus 0, which is 1, right? So it implies limit x tending n tending toward infinity, f of x is 1. This is what we have now. Is this clear so far? Clear? Okay. If it is clear, so now let's again find the limit of h of x. So what I'm going to do, limit n tending towards infinity, h of x we will find. How much it is? It is nothing but limit n tending towards infinity. What is h of x? N upon n square plus 1 plus n upon n square plus 1 plus n upon n square plus 1. So for up to n upon n square plus 1. Clear? How much it is? It is limit n tending towards infinity. How many terms are there? N terms, right? So n into n square plus, sorry, n into, one second. What is this? N into n upon n square plus 1, right? So we will get limit n tending toward infinity, n square upon n square plus 1, right? So as you can see, it is infinity upon infinity form, right? So what do we do? Divide numerator and denominator with n square, right? So limit n tending toward infinity, it will becomes 1 upon 1 plus n square, right? So now substitute n equal to infinity, we will get 1 upon 1 plus 0, which is 1. So it implies limit n tending toward infinity, h of x is 1, right? Is this clear? Is this clear? Tell me quickly in the chat box, is this clear? Or is there any doubt regarding this? Okay, if it is clear, so it means that, so since f of x is less than equal to g of x is less than equal to h of x, and limit n tending toward infinity, f of x is equal to limit n tending toward infinity, h of x, which is equal to 1. So according to sandwich theorem, we can say that limit n tending toward infinity, g of x कितना होना चाहिए? 1. Clear? Is this clear? Right? So hence limit n tending toward infinity, g and gx क्या था? The given expression. Gx is given expression, right? So hence limit n tending toward infinity, n upon n square plus 1 plus n upon n square plus 2 plus n upon n square plus 3 plus n upon n square plus n. कितना आएगा? 1. So this is our answer. Is this clear? So this is the answer. Is this clear, students? Tell me quickly in the chat box. Is this clear or not? JNV Ballari, JNV Chitradurga, JNV Ahmednagar. Everyone, please quickly let me know in the chat box. Is this clear or not? Clear? Quickly. Yes, very good, JNV Ballari. Very good. Okay, so as you can see, so now you are realizing the application of the sandwich theorem, right? we have to find the limit of this expression. So what I did, I remember that this expression is nothing but between n upon n square plus 1 plus n upon n square plus 1 and so forth. And this is greater than n upon n square plus n upon n square plus n, like that. Okay. So then individually I find the limit of f of x and h of x, right? See, for sandwich theorem to be applicable, limit of f of x and h of x should be equal, right? Limit of f of x and h of x should be equal. Okay. If they are not equal, then you cannot say. Okay. For example, what I mean to say is, let's suppose this is h of x and this is f of x. Okay. Is this clear? And at x is equal to a, limit x tending toward f of x is L1 and limit x tending toward h of x is L2. And since my g of x is always between f of x and h of x, so g of x तो ऐसे कुछ भी हो सकता है ना, right? As you can see, g of x की limit is can be between L1 and L2, right? So that's why for sandwich theorem to exist, limit towards f. So for sandwich theorem to applicable, limit x tending towards a, f of x should be equal to limit x tending towards a, h of x. Clear? Is this clear? Quickly let me know in the chat box, everyone. Is this clear or not? Is there any doubt, everyone? Students, is there any doubt? Any doubts? Okay, very good. If there is no doubt, so shall we proceed further? Okay. So let's solve this question. Okay, this question. This is the question from the last class. As time was up, so I was not able to solve this question in the last class. So let's solve this now. So it is saying that limit x tending towards 0, e raised to the power ax minus e raised to the power bx upon x. As you can see, as x tending towards 0, it will be 1 minus 1. So it will be 0 by 0 form, right? So we have to find the limit of this. Clear? Clear? So how we are going to find it? Tell me, student, first of all, limit x tending towards 0, e raised to the power x minus 1 upon x कितना होता है? 1. Limit x tending towards 0, e raised to the power x minus 1 upon x is 1. From the last class, we know that, right? In the last class, we have seen from the important result, right? So what I'm going to do now, students, pay attention. It can be written as limit x tending towards 0. Take e raised to the power bx common. Take the e raised to the power bx outside. So this will become e raised to the power ax divided by e raised to the power bx minus 1 upon x, right? Again, can I write it like this? Limit x tending towards 0, e raised to the power bx, and this is e raised to the power ax minus bx minus 1 divided by x, right? So this becomes limit x tending towards 0, e raised to the power bx. So what I'm doing is multiplying. This can be written as a minus b times x minus 1 upon x. So what I'm doing is multiplying and dividing with a minus b in the numerator and denominator. Clear? So tell me, what is the limit of this expression? This expression. Limit x tending towards 0, e raised to the power elephant minus 1 upon elephant, right? So this will give us 1. Yes or no? Or you can say that what is becomes? It becomes limit x tending towards 0, a minus b into e raised to the power bx into e raised to the power a minus b times x times minus 1 divided by a minus b into x, right? So now we can divide the limits, right? Now we can divide the limits. Since a minus b is constant, so a minus b will come outside into limit x tending towards 0, e raised to the power bx into limit x tending towards 0, e raised to the power a minus b into x minus 1 upon a minus b into x, right? So individually we can find the limit. This is a minus b into what is this limit? This is not an indeterminate form. So we can directly put x is equal to 0. So it will give us 1 into, what is this? This is from the important result, right? This is from the important result, right? E raised to the power elephant minus 1 upon elephant, where elephant is tending towards 0, right? This expression is tending towards 0, right? So it will give us 1. So it means answer is a minus b. So this is our answer. Is this clear? Is this clear? Show hands in the chat box if it is clear. If this question is clear, please everyone reply in the chat box. Reply in the chat box with clear. Everyone, quickly let me know in the chat box, everyone. This question is clear? Okay, very good, very good. Okay. So if it is clear, shall we proceed further then? Shall I proceed further, students? Very good, Janvi Balari. Very good. Okay, if it is clear, so let me, so I am giving you 1 minute, student, solve this question. Okay, this is very similar to the question that we did just before. Okay, so you have 1 minute, find the limit of this expression. Everyone, you have 1 minute, start solving this question. Solve this now. Find the limit, everyone. You have 1 minute, students. Solve this question. Janvi Balari, Janvi Chitra Durga, Janvi Ahmednagar, everyone. Solve this question and let me know the answer. It is very similar to the question we did just now. Okay. Everyone, quickly. What is the answer? Please reply in the chat box when you solve this question. Okay. Reply in the chat box with answer, everyone. 30 seconds left. Everyone solve this question quickly. What is the answer? Students? Anybody? Anyone? Okay. Everyone, then pay attention here. Everyone pay attention. So this is written as limit x tending to, सबसे पहले what is this limit? सबसे पहले as x tending towards 0, 1. Okay, so Janvit Bellari is saying 1. Okay, well, let's see. So put x is equal to 0. You will get e raised to the power 0 minus e raised to the power 0 upon 0 minus 0. So it means it is a 0 by 0 form, right? It is a 0 by 0 form. What I'm doing is take e raised to the power x common. E raised to the power x common. So what we will get? E raised to the power 10x minus x minus 1 divided by 10x minus x. Right? Directly you can say that what is this? E raised to the power elephant minus 1 upon elephant, where elephant is tending towards 0. Right? 10x minus x को elephant मान लो, so e raised to the power elephant minus 1 upon elephant, where elephant is tending towards 0. So what is the limit? 1. Right? So you can say that it can be written as limit x tending towards 0, e raised to the power x into limit x tending towards 0, e raised to the power 10x minus x minus 1 divided by 10x minus x. Since it is not an indeterminate form, so directly we can put x is equal to 0. So we will get 1 into, this is e raised to the power elephant minus 1 upon elephant, where elephant is tending towards 0, right? So how much is the answer? This is 1. So 1 into 1. So answer is 1. So yes, very good, JNV Bellari. Okay, very good, very good. So answer is 1. Okay, is this clear now? Is this clear now? Or do you have any doubt? Is this clear? Everyone, please reply in the chat box. Clear? Okay. If it is clear, so shall I proceed? Okay. So students, so we have seen the sandwich theorem and we have seen some of the questions from the last class. Okay, if the e raised to the power x minus 1 upon x, right? How we solve the standard limits. Okay, so there will be some manipulation with the standard limit. So as long as you can convert that in terms of the non limits, so we can directly find the answer. Okay, so I don't need to find the now this limit, right? Because I know that limit x tending towards 0 e raised to the power x minus 1 upon x kitna hota hai? 1. So I can use this result to find these limits. Okay, is this clear? So that's why these important results are very important. So sometimes what happens in the big expression, you can convert some of them in the standard results. So you can find that limit and then you can proceed. Okay, is this clear? Okay, if it is clear, then let's proceed further. So now let's talk about the 1 raised to the power infinity theorem. Okay, so students, what happens is in 1 raised to the power infinity, there is strictly a procedure to solve those limits. Okay, so every time whenever you will be seeing 1 raised to the power infinity, we will be using a procedure to find that limit. Okay, okay, the proof of it is not important, but the result is important. Okay, so 1 raised to the power infinity says that, everyone, 1 raised to the power infinity says that if limit x tending towards a f of x is equal to 1 and limit x tending towards a g of x is infinity, then limit x tending towards a f of x raised to the power g of x. So as you can see, as x tending towards a, f of x will tends towards 1 and g of x will tend towards infinity. So this is a form of 1 raised to the power infinity. Yes or no? So how we solve the 1 raised to the power infinity? We solve it like this. It can be written as e raised to the power limit x tending towards a f of x minus 1 into g of x. Okay, is this clear? So it can be written as e raised to the power limit x tending towards a f of x minus 1 into g of x. So whenever you will see 1 raised to the power infinity, so we will convert that into this form and find the limit of this. That will give us the answer. Is this clear? Is this clear? Clear? Okay. So everyone, please, some of them is thinking that's a 1 raised to the power infinity, so 1 hota hai, then why we are finding the limit? Yes, 1 raised to the power infinity is 1. Exactly 1 raised to the power infinity is 1. But this time, this is tending towards 1, right? X is not equal to a. So f of x will not be exactly 1, right? This is a tending situation, right? So this f of x is tending towards 1. So it means whenever our expression is in the form of tending towards 1 raised to the power infinity, right? So we use this formula. Clear? But 1 raised to the power infinity is 1 always. Okay, exactly 1 raised to the power infinity is 1. Here this is tending towards 1. Okay, please note the difference. This is tending towards 1. So that's why it is an indeterminate form. Clear? That's why it is an indeterminate form. So that's why we need some method to find that limit. Is this clear? And this is exactly 1. Exact 1. Exact 1. Is this clear? Tell me quickly in the chat box. Is this clear or not? Do you have any doubt regarding this? So whenever we have 1 raised to the power infinity, we can write this as e raised to the power limit x tends towards a f of x minus 1 into g of x. Clear? Is this clear? Any doubt so far? Okay. So student, in 1 raised to the power infinity, there are some important results also. Okay, there is one important result that you have to remember it directly. Okay, so this is the result. Limit x tending towards 0, 1 plus x raised to the power 1 upon x, or limit x tending towards infinity, 1 plus 1 upon x raised to the power x. This is equal to 1. Clear? Why this is and this is equal? Because let 1 upon x is equal to y. So as x tending towards infinity, y will tend towards 0. So this is nothing but limit y tending towards 0, 1 plus y into 1 raised to the power y. See, this and these are interconvertible. Okay. So whenever you have like this, so you can directly say that limit is e, or you can directly prove it also. Okay. You can directly prove it also. So proof dekh lo. Limit x tending towards 0, 1 plus x raised to the power 1 upon x. So this is 1 raised to the power infinity terms, right? As x tending towards 0, this is 1 plus x is tending towards 1 and 1 upon x is tending toward infinity. So this is 1 raised to the power infinity. How we are going to solve it? Using the formula. It can be written as e raised to the power limit x tending towards 0 f of x minus 1 into g of x. So my 1 minus 1 is cancelled out. So it is nothing but e raised to the power limit x tending towards 0, x into 1 upon x, 1. So this is e only. Clear? But this result you have to remember, okay? Limit x tending towards 0, 1 plus x raised to the power 1 upon x कितना होता है? E. Is this clear, everyone? Please let me know quickly in the chat box. Is this clear? Any doubts? Any doubt, students? Clear है? Okay. If it is clear, then let's solve this. So this is another important result, everyone. This is another important result. Okay. What is this saying is limit x tending towards 0, ln 1 plus x upon x. ln 1 plus x upon x. This is also 1. Okay. I can prove it by using the two methods. Okay. First of all, let's see the proof. You will understand. Okay. This is limit x tending towards 0, ln 1 plus x upon x, right? As x tending towards 0, it will become ln 1 upon 0. So 0 by 0 form, right? So 0 by 0 form hota hai, we can directly use the L'Hopital rule, right? We can directly use L'Hopital rule, right? Is this clear? So L'Hopital rule lagao. Limit x tending towards 0. Differentiation of ln 1 upon x is 1 upon 1 plus x into differentiation of 1 plus x is 1. Divided by differentiation of x is 1. So now we can directly put x is equal to 0 because this is no longer indeterminate form, right? So directly we can put the x is equal to 0. So put x is equal to 0, we will get 1 upon 1 plus 0, which is 1. Clear? So this is method 1. Is this clear? Using L'Hopital rule, we can also find the limit. Okay. What is the method 2? Method 2 is, everyone pay attention. And this is very important concept also. What I'm going to tell you in the method 2 is very important concept. Okay. Please pay attention now. Limit is limit x tending towards 0, ln 1 plus x upon x, right? Can I write it like this? This can be written as limit x tending towards 0, 1 upon x into ln 1 plus x, right? So can I write it like this? Limit x tending towards 0, ln 1 plus x raised to the power 1 upon x, right? ln 1 plus x raised to the power 1 upon x. Another 1 upon x will come in front. So this is same as it is, right? Now tell me this expression 1 upon x, this expression I'm talking 1 upon x, 1 plus x raised to the power 1 upon x is 1 raised to the power infinity, right? This is the indeterminate form, right? So whenever this happens, this ln is not contributing anything in the indeterminate form. The indeterminate form is inside the ln, right? The indeterminate form is inside the ln. So you can directly take the limit inside of the ln. So means it can be written as ln of limit x tending towards 0, 1 plus x raised to the power 1 upon x. Is it clear? Is it clear? The indeterminate form, which is 1 raised to the power infinity, was happening inside of ln, right? Inside of the function ln, right? So ln, the logarithmic function, is not contributing anything to make it into the indeterminate form. The indeterminate form is inside of the logarithmic function, right? So I can take the limit inside. Is this clear? And now this is from the important result, limit x tending towards 0, 1 plus x raised to the power 1 upon x is e. So this is nothing but e. And ln e is 1. So see, answer is 1. Is this clear? This is really important steps. Okay, in many questions you will find this step. Okay, very important step. Okay, please remember, if inside of function, let's say if I ask you something like, if inside of some function, let's say limit x tending towards 0 sine x upon x. Okay, as you can see, the 0 by 0 form is now creating inside of sine, right? Inside of sine, the 0 by 0 form is creating, right? So I can write it like limit, I can write it like sine of limit x tending towards 0 sine x upon x, which is 1. So it will give us sine 1. Is this clear? So whenever the things like this happen, that the indeterminate form is forming inside of the function, okay? The function itself is not contributing anything towards the indeterminate form. So what we can do, we can take our limit inside the function. Is this clear? Please quickly let me know in the chat box. Is this clear? One second. Sorry, I dropped my pen. Okay. Is this clear? Quickly let me know in the chat box, everyone. Quickly let me know. You have any doubts? Janvi Balari, Janvi Chitra Durga, Janvi Ahmed Nagar, please let me know in the chat box. Is there any doubt? Clear? Okay. If it is clear, then let's proceed. So let's solve this question, okay? Let's solve this question. It is saying that, yes, very good, Janvi Balari, very good. So it is saying that limit x tending towards 0, 1 plus 7x raised to the power 5 upon x, right? As you can see, as x tending towards 0, so this expression is tending towards 1 raised to the power infinity, right? So it means if anything is form of 1 raised to the power infinity, we can directly use the result, okay? E raised to the power limit x tending towards 0, f of x. F of x is 1 plus 7x. F of x minus 1 into 5 by x, right? So this can be written as e raised to the power limit x tending towards 0, 7x into 5 by x. So this x and x cancel out. So it becomes e raised to the power limit x tending towards 0. How much it is? 35, which is e raised to the power 35. So this is your answer. Is this clear? Very simple question, right? Very trivial question. Okay, it just you become comfortable in solving the 1 raised to the power infinity. Okay, so far what we were doing, we were using the L'Hopital rule, factorization, rationalization, double rationalization, or by creating the infinity in the denominator, right? But whenever we have 1 raised to the power infinity form, we use directly the formula. Okay, so that's why this formula is important. Okay, there is no other method to solve this kind of questions. Okay, is this clear? Am I clear now? Okay, if it is clear, so let's proceed further. Okay, so again, so now I'm giving you 2 minutes, student. 2 minutes you have solved this question. So again, let me just tell you hint. N tending toward infinity, 5 raised to the power 1 plus 1 by n plus 3 raised to the power 1 by n minus 1 raised to the power n. This whole expression raised to the power n. So as n tending toward infinity, this will become 5 raised to the power 0 plus 3 raised to the power 0 minus 1. So it will become 1 raised to the power infinity. So again, it is in the form of 1 raised to the power infinity, isn't it? So you have 2 minutes now, everyone. Solve this question and let me know the answer quickly in the chat box, everyone. Quickly let me know the answer in the chat box. Use the formula, you will get the answer, okay? Use the formula, you will get the answer. Everyone, you have 2 minutes. Start solving now. You have 2 minutes, everyone. Tell me the answer quickly. Please reply in the chat box when you get the answer of this. Anybody got the answer? Anyone? Students, anybody got the answer? Reply me in the chat box. Jenny Balari, Jenny Chitra Durga, anyone? Anybody got the answer? Okay. So let me solve it then. Okay. Everybody please pay attention now. Everyone please pay attention here. First of all, this is a form of 1 raised to the power infinity, right? So again, what we will do? This will be written as e raised to the power limit n tending towards infinity f of x 5 raised to the power 1 by n plus 3 raised to the power 1 by n minus 1. This is f of x minus 1 into n, right? Is this clear? I just applied the formula, nothing else, right? E raised to the power, this can be written as limit n tending towards infinity. Can I write it like this? 5 raised to the power 1 by n minus 1 plus 3 raised to the power 1 by n minus 1 whole divided by 1 by n. Can I write it like this? Right? Okay. So for time being, let 1 by n is equal to x. Okay. 1 by n equal to x, or you can assume any variable, doesn't matter. Okay. So as n tending towards infinity, x will tend towards 0, obviously, right? So it will become e raised to the power limit x tending towards 0, 5 raised to the power x minus 1 plus 3 raised to the power x minus 1 whole divided by x. Okay. Okay. Clear? So can I write it like this? It will become e raised to the power. Now separate the limit. Okay. Separate the limit. It will become e raised to the power limit x tends towards 0, 5 raised to the power x minus 1 upon x plus limit x tending towards 0, 3 raised to the power x minus 1 upon x. Okay. And do you remember this formula? Everyone, do you remember this formula? We know, I think only I am the person that know this, okay, but still I am writing. We know, okay, that limit x tending towards 0, a raised to the power x minus 1 upon x. In the last class, I have told you, okay, from the important result, limit x tending towards 0, a raised to the power x minus 1 upon x is nothing but ln, right? So it means this can be written as e raised to the power limit x tending towards 0, 5 raised to the power x minus 1 upon x is ln 5 plus 3 raised to the power x minus 1 upon x is ln 3. So it becomes e raised to the power ln 15, which is 15. So this is our answer. Is this clear? Please remember the formulas, okay? The important result you have to remember. Important result, series expansion, you have to remember, okay? They are really, really important, okay? Tell me quickly in the chat box if it is clear. Any doubt, students? Any doubts? Clear? Janvi Balari, Janvi Chitra Durga, Janvi Ahmednagar, do you have any doubt? Please reply Janvi Ahmednagar and Janvi Chitra Durga. Janvi Chitra Durga, Janvi Ahmednagar, please reply. Yes, very good, Janvi Balari. Janvi Chitra Durga, Ahmednagar, do you have any doubt? I'm asking. Do you have any doubts? Please reply me in the chat box quickly. Okay, very good, very good. What about JNV Chitra Durga? Very good, JNV Ahmednagar. JNV Chitra Durga, do you have any doubts? Please reply. See, students, whenever I ask something, please try to reply in the chat box, okay? It just shows me that you are attentive in the class, okay? Okay, yeah, very good, JNV Chitra Durga. Okay. Okay, very good, very good. So if it is clear, let's proceed further, okay? So now this question you have to solve it in your homework. Okay, this is your homework question. Okay, again it is again 1 raised to the power infinity form. You have to solve it in your homework. Okay, this is your homework and this is your homework. Okay, this is really important. The result of this you have to remember. The first thing in the tomorrow's class I am going to solve this question. Okay, so you have to solve this. Okay, these two questions are your homework. Okay, so now let's come back to this question. Okay, again really important question. Concept wise is very important. I think in the last class we have solved one of those questions, right? Where some limits is given and they ask you to find the unknown. Okay, so the question is limit x tending towards 0, a sin x minus sin 2x divided by sin 10 cube x is finite, then find the limit, and the value of a. Okay, we have to find this unknown a and the value of this whole limit. Okay, really important. As I have told you in the last class, these type of question you will see very frequently in the exam. Okay, in JEE Mains, JEE Advanced, in any other KCT exam, you will see frequently. Okay. So first of all, student, solution is limit x tending towards 0, a sin x minus sin 2x divided by 10 cube x. Okay, 10 cube x. It is a, as x tending towards 0, it is a 0 by 0 form, right? Okay, so what I'm doing is I'm dividing by x cube and multiplying with x cube. Okay, why you will now see why I'm doing this. This will become limit x tending towards 0, a sin x minus sin 2x upon x cube, right? Because the limit of this I know already, right? Limit x tending towards 0, 10x upon x कितना होता है? Everyone, limit x tending towards 0, 10x upon x is 1, right? So I can use the fundamental theorems of limit and separate the limit. So it can be written as limit x tending towards 0, 10x upon x ka whole cube, which is 1, right? So this becomes limit x tending towards 0, a sin x minus sin 2x divided by x cube. Clear? Any doubt so far? Clear, right? Okay. Everybody knows that what is sin 2x? Sin 2x is 2 sin x cos x, right, upon x cube. You can take the sin x common, right? You can take the sin x common. So take the sin x common, everyone. This will become x tending towards 0. Sin x को common ले लो. This will become a minus 2 cos x. And I can separate this x cube as, here I can write it as x square and here I can write it as x. Okay. So again, the limit of this I know, right? Limit of x tending towards 0, sin x upon x we know. So I can separate the limit again. Okay. Again, using the fundamental theorems of limit, I can write it like this. Limit x tending towards 0, sin x upon x into limit x tending towards 0, a minus 2 cos x upon x square. Clear? And what is this limit? 1. So it will become 1 into limit x tending towards 0, a minus 2 cos x upon x square. Clear? Is this clear? Is this clear? Okay. So student, the question is saying that now the question is reduced like this. It is nothing but limit x tending towards 0, a minus 2 cos x divided by x square. So question is saying that limit of this expression is finite. Okay, limit of this expression is finite. The question is saying, right? So see, now you will remember, now you will understand the application of series expansion. So what is the expansion of cos x? Expansion of cos x is 1 minus x square by 2 factorial plus x raised to the power 4 upon 4 factorial, so on, right? Divided by x cube, x square. right? So it becomes limit x tending towards 0, a minus 2 plus 2x square by 2 factorial minus 2x raised to the power 4 upon 4 factorial, so on, divided by x square, right? Since the limit of this is finite, so as x tending towards 0, this denominator is 0. So it means numerator should be towards 0. Yes or no? As the limit of this expression is finite, so numerator and denominator should tend towards 0, right? So it implies as x tends towards 0, numerator should also tend towards 0. So numerator में x को 0 डालो. So we will get a minus 2 plus 0. So it implies a minus 2 should be equal to 0. So it implies a is equal to 2. Clear? A2 आ गया. Is this clear? Is this clear or not? Right? If a is equal to 2, so now we can directly find the limit, right? Now we can directly find the limit. What is the limit? It is limit x tending towards 0. Put a equal to 2 in this expression. What you will get? 2x square by 2 factorial minus 2x raised to the power 4 upon 4 factorial, right? 2x square by 2 factorial minus 2x raised to the power 4 upon 4 factorial, and all the terms will be of higher power, right? So like this, infinity divided by x square. Now separate the limits. Now divide this. Divide by x square, you will get 1 minus 2 upon 4 factorial x square, so on so forth, right? Because each of these term, upcoming term, will have the power greater than 2. So whenever you will divide with x square, there will be at least single power of x will be remaining, right? So now you can now we no longer have indeterminate form, right? We no longer have indeterminate form. So now directly put x is equal to 0. So we will get 1. Clear? So the answer is 1. So it implies a is equal to 2 and limit is equal to 1. So this is our answer. Clear? So this type of question, one of this question we have done in the last class, where the infinity upon infinity form was creating, right? Here 0 by 0 form is creating. Is this clear? Tell me quickly in the chat box. Is this clear, or do you have any doubts? Students, is this clear? Any doubts so far? Clear? Okay. So if it is clear, students, so similar to this, I want to give you one more question as your homework. So this is the question you have to do in your homework. Okay. Similar है, काफी similar है. In now what is given? The limit of this expression is given 2. So you have to find a, b, and c. Okay. So one thing you can do is, since limit is finite and denominator is tending towards 0, so it means numerator should also tend towards 0, right? It should be 0 by 0 form for limit to be exist, right? So एक वहां से relation आ जाएगी. Then what you can do is expand e raised to the power x, expand cos x, expand e raised to the power minus x, and try to evaluate how I can make something 0 and for what is the condition for this limit to be exist. Okay, is this clear? So this question you have to do in your homework. Okay, tell me quickly, is there any doubts from today's class? Students, is there any doubts from today's class? Any doubts? All clear? Okay. Thank you, everyone. That's all for today's, everyone. Okay. So in the next class, we are going to solve these questions, and then we will solve more questions on the limits. Okay. So more or less the concept of the limit, that all the concept from the limits is mostly over. So we will just solving the more questions, some good questions. Okay. For the practice in the next class. Okay. Thank you, everyone. Thank you. Take care. Okay. I'll see you in the next class. Okay. Bye, everyone. Take care. Take care.